Tonight's video is section 1.4, the intermediate value theorem, IVT. Our homework tonight in section 1.4 is 75 through 78 all, 83 through 86 all, 87 through 89, 91, and 94. The intermediate value theorem. If my function f is continuous, which means I don't pick up my pen at all, on some closed interval, so on the x-axis from A to B, whatever that is, and k is any number between f of a, the y output, if this is the x value, this is the y value, x value, y value, and k is any number between these two outputs, then there is at least one number c in the domain between a and b such that the output f of c is equal to k. It's a mouthful. Let's see what it looks like in a picture. Let's see if I can get this a little higher. So clearly f is continuous, and it's continuous within the closed interval from A to B. Again, closed just means I get to use the points A and B. It's not a parenthesis where I go up to A and don't touch it. So in between, it is clearly continuous. And I even sketched up there the outputs. There's f of A, there's f of B. And it says that k is any number between f of A and f of B. So this is some k here. Then what? Then there is at least one number c in A to B such that f of c equals k. So I don't know, let's put it here. Here's a c. And yes, k will be between f of A and f of B. If I put the c here, it's going to be between f of A and f of B. If the c was here, yes, k is between f of A and f of B. That's all that there is stating. That is an existence theorem. That there exists at least one number c in A to B such that f of c equals k, and that k has to be between the two outputs. Let's look at one more graph. Here's another function. And so the closed interval from A to B, in between there, that function is continuous. And I meant to draw that more forever. And so what I did is I drew the outputs. I went down and I touched the graph. So here's the output for f of A. Maybe that's like a -5. And then over here, maybe this is a +5. So it states by the intermediate value theorem that if the function f is continuous in the closed interval from A to B, that there exists some c in between A and B such that the k is in between f of A and f of B. And no matter where I put the c, I can put the c here. The k is in between. I could put the c here. The k is in between. This is an important theorem for the AP test. IVT. So the intermediate value theorem is often used to find zeros of a function on a closed interval. So I just drew a picture of one. I'll draw a picture again in a minute. Let me first write this out again. If f is continuous on some closed interval from A to B, and again, this is to find the zeros, and f of A, that y output, and f of B, that y output, differ in signs. One's positive and one's negative. Then by the intermediate value theorem, it guarantees the existence of at least one zero of f in the closed interval from A to B. This is a way to find zeros. So let me draw a picture of that. In fact, I've already done that once. Draw another one. So here is my function f. On the closed interval from A to B, it is clearly continuous in between. I'm really not asking about outside of the closed interval. And so that f of A is here and that f of B is here. So again, it says if f is continuous, well, yes, on the closed interval, and f of A and f of B differ in signs. Well, yes, one is negative, one is positive. Then, by the intermediate value theorem, it guarantees the existence of at least one zero, because if my y is negative and this y is positive, the only way to get there is it must cross over the x-axis. So here is my 0. Here is C, and K equals 0. There is my 0. If my y output goes from negative to positive, I must cross over the x-axis once. Crossing over happens to be my 0. There's the C, and K equals 0. Let's look at this algebraically. I have some function, x cubed plus 2x minus 1, and there it is, the closed interval from 0 to 1. Now this is a cubic function. It has no holes. So between 0 and 1, clearly it is a closed interval. And so what I need to do is what I'm looking for is if there is a 0 in between 0 and 1 on the x-axis. So what I have to do is I have to show that f of A and f of B differ in signs. In other words, the endpoints of the closed interval. So f of 0, I put 0 in for x, all I get is negative 1. I put in the other endpoint 1 for x. 1 plus 2 minus 1, that equals 2. So the sign is negative and positive. I can go straight to the conclusion. F is continuous on the closed interval from 0 to 1, and f of 0 and f of 1 differ in signs. So, by the intermediate value theorem, it guarantees at least one 0 in 0 to 1. It looks something like this graph. At 0, my y is negative 1. At f of 1, my output is positive, therefore there must be at least one 0. There could be more. Between 0 and 1, that function could go like this. By the intermediate value theorem, it just guarantees at least one 0. It's the only way you can get from a negative output to a positive output, or a positive output to a negative output. And what I also demonstrated here is how to write the answers in the homework for numbers 75 through 78, because it's going to ask you to use the intermediate value theorem to find the zeros. Thank you.